Hello everyone and welcome to this workshop. My name is Niker Zetic and I'm a DevRel at Flare. In this lesson we're gonna look at Flare's secure random protocol. We will also see how it can be used in a Solidity contract. In the first part of this workshop we'll discuss what the difficulty is with getting a random value, why we need it on Flare, and how we acquire it. In the second part, we'll look at how we can access Flare's random number in Solidity. We'll also see an example contract that uses the secure random. At the end, we'll have a Q&A section, so please save your questions for then. There will also be a link to a quiz which can win you a whole suite of Flare merch, so stay tuned for that. First of all, what is the main problem with random numbers in computers? It's difficult to generate them since computers are deterministic machines, whereas a random number is clearly not. So we usually rely on pseudo-random algorithms or on capturing some noise from the environment. An additional problem with blockchains is that protocols must be deterministic. That's because all steps involved have to be replicated on each node's virtual machine. A random number is typically implemented as a hash of something that cannot easily be predicted or manipulated. But you need to be careful because certain things that we think are random, in fact, aren't that random. For example, a timestamp. A validator could have multiple timestamps, hash them, and choose one that gives them a desired hash. The same goes for block height, block hash, and the sender address. There could be multiple instances of that hashed and the most desirable hash chosen. This means that we are facing an intriguing challenge. Nonetheless, we need a random number generator on the Flare chain. The most prominent use is with deciding stake for each voting round. A reasonably good solution is random sampling. This is the protocol that Flare implements, and it's the reason why we need access to random numbers. So now for how the randomness is actually implemented on Flare. We actually rely on our data providers to generate a random number. They are each required to provide a random number every time they submit a price to FTSO. So what they are sending is a hash of the address, voting epoch ID, the random number, and price data. All their random numbers, the random numbers of all the data providers, are added together, and a catch-check is used on the final sum. This random number is then available to everyone. We get a new random number every 90 seconds. The number is between 0 and 2 to the power of 256. If we need a lower number, we can just divide it modulo the number we want. So for example, if we wanted to simulate a roll of a 6-sided die, we would just take the random number we get from Flare and modulo 6. Now, how can we actually access the random number that Flare provides through code? It is actually quite easy to use, and we will now demonstrate how we can access it. Feel free to follow along on your devices. The starting point for us will be the Flare Developer Hub. So I'll just exit the slides and show it to you. So on Flare Developer Hub, you can go to get start building, then click on the network tab and network guides, and under that you will see secure random numbers. Here described is the whole process more in detail, but what we'll look at now is the button here, open in Remix. If we click that button, a project will open up in Remix that already has the secure random number implemented with additional Flare contracts. Let's look at the contract. Let's look at it line by line. First of all, we import the contract registry. The contract registry library is a library in Solidity that helps us access official Flare contracts with ease, and also makes sure that we are always accessing the correct version of the contract. That is, if we redeploy the contracts, the library will point to the correct one. The second import is the random number v2 interface, which exposes all the methods of the real contract. Within the contract, we reference the random number contract. We set it within the constructor method. We do this so that we already have it available within the contract. The last part of the contract is the get secure random number function. This function accesses the random number of the Flare protocol. The three return values are, of course, random number itself, the timestamp of when the corresponding voting round ended, and an additional flag is secure. This last thing basically informs us whether there has been an attempt to tamper with the random number. Why the last part, you may ask? If the system detects that the data providers might have tampered with or tried to manipulate the random number, it informs us of that. You can still use it. It is still very secure, but it is a good diagnostic. Core Flare protocols usually wait for the secure number. But fear not, the data providers are heavily penalized if they even make such an attempt, if they even attempt to try and manipulate the number. And that's it. The random number is ours to use. We can already compile the code by going to the Compile tab on Remix. So we make sure that we use a good compiler version, and then we can just click Compile and run secure number, secure random consumer. Once deployed, we can also look under the deployed. After we have compiled the contract, we need to deploy it on chain. To do that, we go to the Deploy and Run Transactions tab. First of all, we set Injected Provider MetaMask in the Environment drop-down menu. Of course, before that, we need to connect our MetaMask wallet to Remix to actually be able to do that. I have already set up my wallet and ensured that it has enough Coston 2 in it. But if you don't have that yet, you can go to the Coston 2 faucet and gain funds that way. So once we have selected the MetaMask as the injected provider, we can select the secure random consumer contract and then deploy it by clicking the deploy button. We will see in the console that the contract will be created and deployed. So let's just wait for that to happen. Oh yeah, sorry. I forgot to confirm the transaction. So once we have deployed the contract, we can select it under the deployed contracts. Here, we can call it get secure random number method. And we can see that we got a random number. The flag says that it is secure, and this is the timestamp of the voting round ending. So the only thing left to do is to verify the contract. We can do that by first copying the contract address and then go into contract verification tab on Remix. We select the chain, and in our case, that will be Flare testnet Coston 2. We fill in the contract address and then make sure that we are actually verifying the secure random consumer contract. And with that, we click verify and the contract should be verified. So let's just wait for that to verify on Rootscan. And let's see if, well, great. It's yeah, the contract has been verified. So the code has been made public to the Rootscan Explorer. Cool. So that's the simple example. And now I will end the lesson by going to by showing a simple guessing game example. So for that, let's go to the Flare Hardhat starter. This is a GitHub repository. It seems there's a question. Let me just check. Oh, okay. That's for the end of the presentation. Cool. So yeah, if we go to the Flare Hardhat starter GitHub repository, all we need right now is just to get the URL of the repository, because that will allow us to clone it to a remix. We clone it by going to the Git tab, go under clone, paste in the Flare Hardhat starter GitHub URL, and specify that we will be cloning the master branch. There's also a Foundry starter pack available, which is mostly the same. Okay, so once the repository has been cloned, we can look under contracts, and there we can find the simple guessing game contract. What this contract does is, first of all, upon its construction, it allows us to input the maximum allowed value for the random numbers, and then it prompts the user to input a number, and it tells them whether the number they guessed is larger or smaller than the secret random number that it holds. So we can do the same thing for this contract as we did for the previous one. So first of all, let's compile it. Then we deploy the contract. Again, we select injected provider MetaMask. Make sure it's the guessing game. And this time we also need to input the maximum number. It will allow us to guess. And let's just set it on 2, so we have a 50-50 chance to get it on the first try. We again need to confirm the transaction. We are informed that the transaction has been confirmed. And then we can also verify the contract again by copying its address, going to contract verification, verify, and pasting the contract address there, and also finding the guessing game, which conveniently is the last entry. And then just click verify. But under the deploy and run transactions tab, we can also interact with our contract here. We can see that the max number is 2. We can reset the game, which will actually collect the random number from Flare and calculate a secret number, a random number. And let's see if I manage to guess it. No, that's too big, so 0 is the correct answer. But there's one thing to note about the contract I have showed you here, and that is it is fundamentally flawed. The fundamental flaw that this contract here has is that it sets up its secret number by collecting it from Flare once it has been revealed already. So users could easily go and get the random hash themselves and calculate what the random number in this contract would be. The reason why we did this is to allow the back and forth of too big, too small that you usually see in the guessing game examples. But if you were making a real life game, poker, for example, you would actually demand your users to lock in their answers before getting a random number of the upcoming voting round, and you would only acquire the random number after they locked in their answers, and this way you would actually ensure that the random number truly was random and secret. But for this future example, this suffices. Another thing to note is that in that sense, the Flare secure random number is actually a future random number, because you can only use a future value, not a past one, because the past one is not secure anymore. As I've shown, you can access this code and much more through the Flare developer hub. You can also get even more things from Flare Hardhat starter package on GitHub. But otherwise, that will be all, and it's now time for the Q&A So if you have any questions, feel free to ask. Also, let me just put this on. So yeah, any questions? I saw a few questions appearing during the presentation. Um, I just need to figure out where I can see them. Yeah, sorry, where can I see the questions again? Oops. Oh, I see. So the first question is, can the RNG be set to guess from a max number and minimum number? Um, so in the sense, you're asking whether the RNG can be set to guess from that is specifically related to the guessing game, or because yeah, in that case, um, the way that the guessing game is implemented is that the random number is taken from Flare and then just divided by modulo maximum number, uh, or perhaps even maximum number plus one. I'm not sure. Um, and yeah, the way you can guess it is you can get the random number yourself and then just divide it modulo max number, and that's how you would get it. How you would get the secret number. Any more questions? Uh, could this be used for an on-chain roulette? Yes, definitely. Uh, an on-chain roulette would be an easy case of using a random number. But you would have to consider the fact that actually, just as with a real life roulette, users would have to bet on numbers before the random number itself was collected. And I believe that roulette has 37 numbers, right? So all you have to do is obtain the random number from Flare, the secure random, and then divide it modulo modulo 37, and that would be it. Can it be used to shuffle cards in a deck with a bit of tweaking? Um, yeah, probably. Uh, or, I mean, a thing you can always do is have a random number generator and only input the Flair's random number as seed. Uh, so, yeah, because if you provide the random seed to a random number generator, I think that would be fine. But with some creativeness, you can definitely use it to shuffle a deck. But again, you need to keep in mind that you would only shuffle the deck once everyone was locked in with their answers, depending on your use case. Yeah, that was one of the main issues during a hackathon. Random number chain can be a bit complex. Yeah, it can be complex. Oops. Yeah, it can be really useful. Um, it can also be used off chain. So uh, Flare also provides you a truly random number for free. And I think there's an example of how you can use it off chain uh, on the developer hub. Are there any more questions? Are we ready to wrap up? Let's wait for another minute if any more questions come in, and then I think we can wrap up. Of course, if you come up with any additional question afterwards, uh, you're free to contact anyone of us on Flare Team, either through Discord or other channels. I don't see any new questions coming in, so in that case, this concludes this workshop. Thank you for tuning in, and goodbye.